We'll explain each concept one by one. Okay, size of the nucleus. Before dive into the concept, let us understand what we have in the size of nucleus part. In this chapter, in the size of nucleus part, we have first thing, nucleus shape. Okay, first we have nucleus shape. Okay, for all practical purpose, shape of nucleus is regarded as spherical. For all practical purpose, shape of nucleus is regarded as spherical. Okay, and deviation can be 10%. For all practical purpose, shape of nucleus is regarded as spherical and deviation can be 10%. Deviation can be 10%. Okay, this is all about the nucleus shape. We have to discuss the size of nucleus. Yes, I am coming to the point. Let's see the next one, size of the nucleus. Okay, for size of the nucleus. What about the size of the nucleus? If we have these two things, H and Na. For hydrogen, we have two H1. For Na, we have 2311. For this, you can write one proton and one neutron. For this, you can write 11 proton and 12 neutron, right? See, my question is, the size of hydrogen and size of this sodium will be same? Think and answer. See, in hydrogen atom, we have to keep only one proton, one neutron. While in sodium, we have to keep 11 proton and 12 neutron. Size can't be same. Yes. That means what? That means this sodium should be greater. Sodium size, sodium nucleus size should be greater. So on what factor does the size depends? Size depends on the number of nucleons. So experimentally, our scientists concluded experimentally, experimentally, our scientists concluded volume of nucleus, volume of nucleus is directly proportional to is directly proportional to number of nucleons in nucleus. Okay, volume is directly proportional to a volume of nucleus is directly proportional to number of nucleons in nucleus. Okay, volume will be represented by V, number of nucleon in nucleons in nucleus it will be represented by A. Now see further. Here I am erasing this part. Just a small short derivation, you'll get the important formula. Okay, so here you can write V is equal to, sorry, V is directly proportional to A. In place of V, see it is sphere. Yes, we have considered it is sphere, right? Yes, if it is a sphere, so in place of volume, can I write 4 upon 3 pi r cube? Yes, directly proportional to A. So therefore, see 4 upon 3 and pi, they are constant, so I can write that r cube is directly proportional to a, right? So therefore I can write r is directly proportional to a raised to 1 upon 3, right? After removing proportionality sign, everyone knows who will come. Yes, there will be a constant and it will be termed as r naught into a raised to 1 upon 3. And what is this r naught? What is this r naught? What is r naught? R naught is known as R naught is constant, and that constant is 1.2 into 10 raised to minus 15 meter. Okay, R naught is 1.2 into 10 raised to minus 15 meter. So what about R? This will be equal to 1.2 into 10 raised to minus 15 a raised to 1 upon 3. Okay. Okay, so experimentally, volume is directly proportional to number of nucleons. V is directly proportional to A. In place of V, I will write 1 upon 3 pi r cube in directly proportional to A. After removing this proportionality sign and that constant, you will get R naught. What is R naught? R naught is 1.2 into 10 raised to minus 15 meter. Okay. Yes, so this was about the size. If you know A, you'll substitute the value of A, you'll get the value of R. If you just know A, you can find R. Even you can compare by the two radius, which radius is bigger, which radius is smaller, just with the help of this box formula. That's it. Okay, so first we studied what about the nucleus shape. What will be the shape will be spherical. It can have a deviation of 10%. Deviation 10%, you understand? Now that's deviation of 10%. Then second we have size. For size, I explained you that if you have hydrogen, if you have sodium, so which size will be greater? Yes, obviously hydrogen size will be smaller. Why smaller? Because it have to occupy only one neutron, one proton. But sodium, in the case of sodium, the case was different. There we have to occupy 11 proton and 12 neutron. Experimentally, what we got, I explain you that, and how we can derive this R from that equation. This is here. Okay. Third, we have nuclear density. Third, we have nuclear density. Nuclear density. Okay, nuclear density. In nuclear density, we have density formula. What is density? Density is mass upon volume. We have density as mass over volume. What is the meaning of mass? 1 A into 1 atomic mass unit. And what about volume? 4 upon 3 pi r cube. So here it will be equal to A into 1 A mu upon 4 upon 3 pi into what is r cube? R naught A raised to 1 upon 3. So this will be equal to A into 1 atomic mass unit upon 4 upon 3 pi r cube into only A and A will get cancelled, and you will get density value as 1 AMU upon 4 upon 3 pi r cube. We know what is pi r we know what is r cube. What is r cube? In place of r cube you can write as, sorry, this is r naught, and we know the value of r naught. What is r naught? I'm writing here. What is one atomic mass unit? One atomic mass unit will be 1.67 into 10 raised to minus 27, and r naught value will be 1.2 into 10 raised to minus 15. See, you have all the value of the constant. If you substitute this value, you will get density value as 2 into 10 raised to 17 kg per meter cube. Okay, yes, this is our nuclear density. Next, yes, before proceeding further, let's see some questions based on this. See the question. The question is, the ratio of nuclear density of two nuclei having mass number 64 and 125 is, mass number is given. What is the meaning of mass number? Mass number means A1 and A2 are given. Okay. So A1 and A2 are given. We have to find nuclear density. So density will be equal to, see here we have the solution. We have the formula for density. Density will be mass over volume. We have derived this thing now. Yes. So if two masses are given, we have to find the densities. See, this is mass number, not mass. So here in place of volume, what you can write? 4 upon 3 pi r cube. So it will be mass upon 4 upon 3 multiply by pi multiply by r naught a raised to 1 upon 3 ka cube. So this will be equal to mass upon 4 upon 3 pi into r naught cube multiplied by a. Okay, so here what you have, you can say that it is directly proportional to m and inversely proportional to a. Constant, 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 and this is also constant. So therefore you can write density 1 to density 2 will be equal to, directly proportional means m1 over a1, directly proportional to a2 over m2. Now we have m1, we have m2. What is m1? Check. What is m1? Value of m1 65. Okay, value of m2, my value of m1 and value of m2, this is 64. Sorry, this is 64 and value of m2 is 125. This is a2 is 125, a1 is 64. So this will get cancelled by each other and you will get the ratio of density as 1. Okay, yes. Next what? The mass density, the mass density of nucleus of mass number A is how much? Then the options are proportional to a raised to 1 upon 3, proportional to a raised to 2 upon 3, proportional to a cube, or independent of a. Mass density. Check. Okay. If you check this equation, you will come to know that that it doesn't depend upon a. Okay. See, if you check nuclear density, it doesn't depend on a. That means which option will be correct? Option number D. Okay, yes. Let's see the next one. Which of the following get the expression from nuclear radius? Check, check, check. This one, this one, this one, or this one, or this one. See, the radius equation was r naught a raised to 1 upon 3, right? A raised to 1 upon 3. That means what? A raised to 1 upon 3, right? So r naught a raised to 1 upon 3. Check. So this equation will be the right A.